All right, good afternoon, everybody. Here to talk about 2.5 modeling ionic bonding. So we've actually done something a little bit like this already. We did a thing where we talked about losing or gaining charge at one point. And I want to help us get back to this to talk about ionic bonding. I think there's a lot of really good stuff in this lesson that'll help you understand it. So first off, you're going to need some things. You're going to need some small objects to represent valence electrons, and you can use like anything you've got around the house. You also need some things to represent atoms, whether they're like a piece of paper or a cup or a piece of fabric or something, anything. Those are all things you can use. And then the final thing you'll need is some pieces of paper that just say outer shell full. I'm going to show you a little bit of what I've got. I have it set up just for me to do, so I can do it for you on the computer. So I've got these circles that represent the atoms. I've got things to represent valence electrons, and I forgot to do a thing that says outer shell full, so I'm going to make that right now. I'll do that real quick. Outer shell full. All right, let's, boom, there we go. I'll make that a little bit smaller, and we'll call it good. Yeah. All right. So I'll have more of those if I need them. Anyway, so back to that. All right. So here's what we're going to do. The first thing you're going to do in the pre-lab is you're going to think about modeling valence electrons. So we just went over this in 2.4. What are valence electrons? So I want you to be thinking about this. What is the atomic number? Is it a metal or a non-metal? So metal and non-metal we did talk about back in some of the earlier lessons. Number of electrons total, and then the number of valence electrons. Assume all of these atoms are neutral at the start, okay? And then think about the number of valence electrons. And we also talked in 2.4 about stealing or giving electrons. Are atoms more likely to steal or give? All right. Think about which ones would steal, which ones would give, and then look at this and think about which ones are going to be pairs. And if you're going to form a pair, I want you to think about, do you think it's likely to be two atoms that are going to both steal, two atoms that are going to both give, or two atoms that are going to steal and give? You know, one steal and one give. So think about that as you're working your way through this. And here's where we get to the lab. So we've got these atoms set up. So I set them up not quite the same order. If you look at mine, I've got chlorine up here, magnesium down here, sodium here. There we go. So let's see. So here's the main thing to think about. Bonds are going to form in the easiest, the lowest energy way possible. So that means if an atom has two electrons to give, it's going to try to give them both to the same atom. So you're going to move grains of rice so that each cup has either 8 grains or 0 grains of rice. So you want it to be completely full or completely empty. And then you want to think about which grains of rice move where. That's ionic bonding. An ionic bond forms when one atom steals electrons and the other atom gives it up, and then they form a charged bond together because one of them is now positive and one of them is negative, and that's what holds those atoms together. That's ionic bonding, okay? Think about which one's positive and which one's negative. So, yep. So, here's what we're going to do. Here's how I'll look at this. If I've got sodium and chlorine and magnesium and oxygen, the most likely thing that's going to happen is this one is going to come over here and be with that. And then now I've got outer shell full for this one and outer shell full for this one, right? Magnesium, what's super likely to happen is that one will move over here, this one will move over here, and now I've got outer shell full, outer shell full. So all of these have full outer shells now, either because they have 8 electrons in what was their valence level before, or if they are sodium or magnesium, their valence level disappeared and underneath it is a full level. All right? So that's what we're looking at there. All right. So now what you're going to do is you're going to do the same thing, but you're going to figure out, is it a metal or non-metal? How many valence electrons does it have? And then I want you to find ways that these will combine. All right? So will lithium combine with chlorine? And right now we're trying to make it just like we just did, a 1-to-1 ratio. So will one lithium atom and one chlorine atom combine and have both of their outer shells fill? Will one lithium atom and one sulfur atom? Will one magnesium and one fluorine? Will one magnesium and one sulfur? All right? So think about that as you're going through. So you can either take a picture, or if you want to do something like I'm doing, you can do this, something like this in Word. You can do something like this in Publisher is what I'm using. There's a lot of different ways to do it. So that's that. One thing to think about, did cups representing metals end up empty or full? Would an empty cup have a positive or negative charge? What about non-metals? They end up empty or full. Would a full cup have a positive or negative charge? Pictures, you can draw them in, you can take pictures, either way. Now, the next thing we're going to do is we're going to do a 2-to-1 ratio. And I want to show you a little bit what that might look like. So I'm going to come back to here, and what I'm going to do is I'm going to create 2 NAs. So if I have something like this, imagine now that I don't have this chlorine. In fact, I have these 2 sodiums and just this oxygen. So goodbye, chlorine. No, really, goodbye, chlorine. Bye. Goodbye. Leave chlorine. All right, so now I've got sodium and oxygen, right? If this sodium gives up its electron, that's cool, but it doesn't fill up the oxygen. So the oxygen needs another one from this sodium, So now I've got 2 sodiums and 1 oxygen, all of which end with this outer shell full, right? So this is a cool way for us to think about this. It doesn't just have to be 1-to-1. It can happen where you have 2 atoms of one kind and 1 atom of another kind, and they fill up each other's shells in this way. It can also go the other way. For example, if I had something like magnesium with 2 valence electrons to give and chlorine that only accepts 1, I could do magnesium gives 1-to-1 chlorine and then another to another chlorine. So those are both examples of a 2-to-1 ratio, and that's something to think about. There we go. Go ahead and think about those questions. Then we've got this game right here. This is a really good game to try playing. I'm going to bring it up so you can take a look at it. It'll only let you play like the first 6 or 7 levels, but I think that's all you really need. So you can work through and play it, and it's super cool because it like gives you feedback on what you're doing right, on what you're doing wrong. It goes through the process of double checking. For some of you, this is going to seem a little slow. Honestly, probably for a lot of you, it's going to seem really slow. After you're a few levels in, you're going to be like, look, yes, I know this. I've done this like 5 times. But if you play through this game, it will help you out. Okay? So you can do the first 6 levels. So you play through it. It's a little bit, takes a little bit getting used to do it because you have to be able to do the things, but it goes through step by step. So here it's like, all right, so here's what you need to do. You need to get a sodium atom in here. And then you need to activate the charge ring. And this I found, at least for me, took some doing because it keeps wanting me to select. So I had to find a way to select in the center, and it did not like doing that for me. There we go. And so that might take a little bit for you to do. You can do this. You can have the chlorine. So you got to activate. And this is where I found the most problems, is like activating the charge ring. Okay, there's that one. And there's that one. Cool. So if it gets frustrating, keep trying. It's really good. It helps you figure things out. And that's all I'm going to say about that game. So coming back to modeling ionic bonding. You've got a few questions to answer about the game to think about, and that's about that. That's all I want to say about this. Good luck with this. I think there's a lot of different ways for you to help out your understanding here. And yeah, I'll see you in the next video.